Question 3. So, first thing to take on board is that the tensions in the two strings are different because we've got two light inextensible strings. So let's call the tension in this string TP and the tension in this string TQ. Obviously this angle here is 35 degrees, angles in a triangle equal 180, and this one is 55. So we need to do two things. We will resolve vertically first of all, then we'll resolve horizontally, and that will basically create a simultaneous equation which we can solve. So resolving vertically, now I've chosen to do TP cos 35 to represent this red force, this component. Equally I could have done TP sin 55, but basically this length here. So that tension there, that component, the vertical component of TP plus the vertical component of TQ, so TQ cos 55, or if you like TQ sin 35, the green vertical component, those two together are offsetting the weight of the mass, which is, because it's got a 2 kilogram mass, so the particle, the weight of the particle, the force of the particle going downwards, the weight is 2g. So the two vertical components, the red bit and the green bit, added together offset the weight. So TP cos 35 plus TQ cos 55 equals 2g. So that's our first equation. Now resolving horizontally, well, there's no weight here, so basically these two horizontal components of the two tensions must cancel each other out, they must equal each other. So we're saying TP cos 55, an adjacent component there, must be offsetting TQ cos 35, that adjacent component here. So that gives us our second equation. So if I rearrange this second one to make TP the subject, so dividing through by cos 55, I'm going to call this equation 3, and I'm going to substitute this back into equation 1, which I've done down here, and then popping it into my calculator and working my way through, I get the tension in Q to be 11.2 newtons, and because the tension in P equals this, now that I know that TQ equals 11.2, I can work out my tension in P to be 16.1 newtons. So they're my two tensions.